In example 2, we have another tan graph, but this one has quite a few more moving parts in it. So we will take it fairly easily and see how we go. So first of all, let's work out the period of this graph. And again, because pi has a period, tan has a period of pi, and in this case, there's an implied number for n there of 1, we end up a period being pi as well. So that's fine. We also should look at the starting value as well, and the start of this graph is, well, we've got a phase shift here of pi on 4, which means the graph is now going to start at pi on 4. And by start, I mean it's where one of the center lines starts, effectively. So the start is equal to pi on 4, so it's good. And we should just note that we've got a domain of 0 to 2 pi. So our graph has to go to 0, but our center point start is at pi on 4, and you'll see that come out in a second. In terms of the asymptotes, we know that the first asymptote is half a period away from the start. So if we look at a half of pi, of course, we get pi on 2. I wonder if I put that in. It's not worth that calculation, is it? So our first asymptote will be at pi on 4 plus another pi on 2. And that'll give us, what's that? That's 3 pi on 4. So that's our starting asymptote. And then we will have plus or minus pi, plus or minus a single period to get to the next asymptote backwards and forwards. Okay, that's all good. But we just need to have that done between 0 and 2 pi, although you'll see me putting in a few more asymptotes just to get a sense of what the graph is doing. Okay, so it's graphing time, and because there's a vertical translation, the first thing we do is we translate our horizontal x-axis guideline, I suppose, upwards or down, in this case up by 1 unit. So we're going to go 1 unit up, and that will give us something like this as our new center line. Remember, that is not an asymptote, that is simply a guideline for where we're going to be drawing our graph, and that is at 1. Okay, well, that's cool enough. We also need a pi on 4 start, so I'll pop that in. So let's put it in about there. That's where our new center line will be, so I'll put a blue dot there to show that I'm going to start my center of my graph from there. And then at 3 pi on 4, we're going to have our first asymptote. And I'll do it in purple just so that it's a different color. So I'm just going to judge it a little bit by eye. So 1, 2, 3, it's about there, I think. Hopefully. There's one asymptote, and then 1, 2, 3 will be another asymptote here. And that's about all I think I need. I don't need any other asymptotes because the next asymptote would be below the y-axis, and I don't need to go below 0, and the next one would be above. I might even just label them as well because then we know what we're going on with, and I'll label them up the top simply because the axis is getting a bit messy down there. So the first one is at 3 pi on 4, and then the next one is another pi onwards, so that's another 4 pi on 4 to make 7 pi on 4. And there's our asymptotes done. Now, you'll notice, well, now we need to draw the lines in, and I guess let's do the easy bits first. The easy bit is to do, well, I've got a center line here, and so part of my graph is going to go from here. There's no reflection, so it's just going to go up. And for the center line here, that'll also go up, and this will also go down like so. Okay, I do have an amplitude that I need to take into account. So really the graph is going to be stretched up by √3. So it's probably more likely going to be like this. Something like that instead of it being as curvy as I made it. But nevertheless, that's pretty well much that done. The reason why I haven't drawn any more is for the following reasons. To go down here, and I'll have to stop at the y-axis because it says to 0. Does it stop here? Or does it stop here? I don't know. So I'm not going to fill it in yet. And similarly, 2 pi is going to go from here to what, here? Or is it going to go here to here? I don't know. So I'm going to leave that, and I'm going to go and do my y and x intercepts first, and then come back and do it. So that's why I've got it in red there, calculated here. I'll keep it zoomed out so you can see the calculations alongside the graph. The y-intercept is, as always with all of our functions, when x equals 0, what is that y-intercept? So let's do that process nice and quick smart. y is equal to the square root of 3 tan of negative pi on 4. 0 minus pi on 4 is negative pi on 4 plus 1. And then the tan of negative pi on 4 is going to look like this. I know the tan of pi on 4, the reference angle is 1, so the tan of negative pi on 4 is going to be in this quadrant here, so that means that tan is negative, and so I'm going to have negative root 3 plus 1, or 1 minus root 3. Now, if you do a quick bit of calculator work, you'll see that that's approximately equal to negative 0.732. Okay, that's just so you know that it's got to be a negative number. So now I can go back to my graph and I can go, oh, good, it's going to actually be here. And I'll do it in red so it sort of relates to the calculated here section. So I'm going to go down about to here, and that's going to be, I'll put 1 minus root 3. I think you could probably get away with just putting the decimal down, but I'll do that. Now I can fill up my graph, and it's going to be sort of going like this, I think, something like that. And it would continue past if I had to do more, but I don't, so I'll just leave it at that. And similarly, because it's going to be symmetrical in a sort of regard, like if I did another asymptote here, it's going to be coming from infinity to that point. I can see that at 2 pi, I'm going to have the same sort of thing, so it's going to be like this, effectively, and this point is going to be 2 pi, comma 1 minus root 3 is that final point. So yes, when you have, this is a bit tricky because of all this, but if you have a fixed domain like 0 to 2 pi, it's a bit difficult, but nevertheless, you do have to work out the endpoints of that by doing some sort of calculation. So that's all good. The only thing we've missed out is the x-intercepts, right? So we can see we've got 2. We should only have 2. So let's have a look at that. How do we do x-intercepts? Well, I'm glad you asked. The way we do x-intercepts is we set y equal to 0 and see where it takes us. So we've got 0 equals root 3 tan x minus pi on 4 plus 1. It's almost always worth more than 1 mark, so I'm going to do a brief bit of manipulation here. So I'm going to subtract 1. I'm going to divide by root 3, and that would give me tan of x minus pi on 4 is equal to minus 1 on root 3. And if I rationalize the denominator, multiply top and bottom by root 3, we would get negative root 3 on 3 is the equivalent, which you could then look up in your table of values, work out the reference angle, then work it out manually, and then you'll get a final answer. Or you could use your GDC if you've got access to it, and this is just a brief reminder on how to do that. So here's my GDC, and I'm going to go solve tan of x minus pi on 4, close brackets, equals negative, I'll even use the fraction button, control divided by, negative root 3 on 3, so negative root 3 over 3 with respect to x, and then we've got to put our domain in as well, so that's control equals bar, and then we're going to go from 0 to 2 pi, so 0 is less than or equal to x, which has to be less than or equal to 2 pi. These you can literally type in the word pi and it will change it to pi's when you've pressed enter, like so. We can see that we've got two solutions here. We've got x equals pi on 12 and x equals 13 pi on 12 as well. So if I go back to my problem, I can see I've written them down here. And then I can finish off my graph by putting in pi on 12 here and 13 pi on 12. And I think that does look about right based upon where I'm at. That's going to be what? That's going to be 9 pi on 12. That's going to be 7 threes, 21 pi on 12. So this looks like a pretty reasonable place that the graph has ended up with. So yeah, quite a few moving parts in that one, but you just break it down into single little steps, work out things as you go along. For this one here, I didn't do a point for scale, and the reason why is because I've actually got 2 points here already, which allow me to have scale to the graph. So I don't need to, but I could have used let x equal pi on 2, and that would have given me tan of pi on 4 in this inside here, and that would have given me root 3 plus 1. So I could have done that if I wanted to have an extra point for scale, but again, because I've already got 2 here, I don't need them. That'll do for this video, I think.